Peter asked me to cover a wider range of topics than just the construction and the nature of your incinerator. So what I'm going to do is extend it further into areas such as why were incinerators built, how they evolved, and the ones at Moore Park, which were the original incinerators before the incinerators shifted to Pyrmont. And then I'm also going to talk about the design, external, and the nature of the furnaces, which did all the incineration of the garbage, and then move on to the problem that you all have. Within 4 years, you'll run out of space to put the garbage in Eastern Creek, and what are you going to do with it then? I'll address that issue. So, a bit of history first, and this is a bit gruesome, but the reality is that there was a very poor public health system within areas such as in London or the major cities of the UK during the Industrial Revolution, because a few hundred years earlier the aristocracy actually effectively captured most of the land in the rural areas and drove the people out. So they went to the cities where they were welcome because they became the workforce for the massive expansion in industries driven by steam engine, since the British were the pioneers in that technology. The catch is that having such a high density of population in the city areas, that the health conditions were poor because things like there was no running water in the homes, there was no sewerage system in the homes, and people often just dug a hole somewhere in their backyard and used that as their toilet system. And you can imagine that when it filled up or rain got into it, it would just overflow into the gutters and then run down into the Thames River. Yuck. So some of the householders, the responsible ones, actually hired a contractor to bail it out and then take it away. So they sold it to market gardens. And you can imagine that the vegetables and the fruit coming back from the market gardens will contain the very germs and viruses that cause the diseases in the first place. So the infant mortality rate from a situation like this was something like 20 to 30% of the children would die before they got to 5 years old. It was really appalling. So you can see there's a whole range of different diseases that ran through whole suburbs, such as cholera, which was very deadly, typhoid, gastro, and there was always a fear that the Black Plague would come back as well. So here is a delightful picture, a drawing of the contractors that actually bailed out the toilet systems into these bigger buckets and then put them on a cart and took them to the market gardeners. Not very appealing having one of these guys walking past your home. So a number of factors drove the idea of putting in incinerators, and I'll go through them one by one. The thing is, the medical authorities at that time believed that disease was caused by something called miasma, which was effectively all the vapours that hung over swamps and low-lying areas. However, there was a doctor called John Snow who took a rigorous scientific approach to studying the problem of cholera, and what he found out by actually mapping the cases of cholera around a certain suburb of London, he found that all of them had been drawing their water from a pump. Since there was no running water, that's what they did. You took a bucket to the pump, you pumped it up and then took it home and used it. So he wrote this up, and the medical fraternity completely ignored it and rejected it. It took them about 12 years before another noted medical scientist did his own research and found out, to his horror, that he was wrong about miasma and that Dr. Snow was correct. And so a big effort was put into cleaning up the water supply system. So the contractors were not allowed to dump the toilet waste into the river, which some people got their water from. They weren't allowed to put it into, say, the catchment area reservoirs or dump it onto vacant land as well. They had to get rid of it effectively and cleanly. So that made a huge difference to the incidence of cholera at the time. And then the next thing that happened was in 1858, the Great Stink, as it was called, because there was a period where it was a very hot summer in London. The tidal flow was very small, and so all the sewage and rubbish, the garbage that was going into the river, just sat there and festered and created a shocking stink, which was so bad that it drove the members of Parliament out of the House, and they just gave up and went home. Fortunately, that forced them to address the issue of getting rid of the sewage waste, and then funding was provided eventually to create that wonderful sewage system. Now, if anybody has watched that TV series, Seven Wonders of the Industrial Revolution, that goes very well into the business of how Basil Gett actually designed and implemented the sewage system of London, which again made a huge difference in the health of the population. What it did effectively was just carry the sewage downstream, and then they released it back into the Thames and flushed it out at high tide. So it just was taking your crap and putting it somewhere else into the river further downstream. Too bad if you lived in the suburb down at the mouth of the Thames. So the next job was to incinerate garbage. Now, by that time, the health authorities realised that rats were a key factor in bubonic plague, and they'd already had a number of waves of black plague coming through the town, and were frightened that if they didn't do something about the garbage and dispose of it safely, then they could have another black plague outbreak. So therefore what they did was decide that the safest way to get rid of all the municipal garbage and stop the rats from feeding in it, as well as the flies and cockroaches and other nasty things, was to burn it. Now, how to burn the garbage? Well, that was an easy job, because who were the pioneers of steam engines and steam systems and boilers? The British. So they just said, why can't we adapt our existing technology for burning coal and then just use it to burn garbage? Because after all, garbage is mostly various hydrocarbons and you can burn it. So away they went. So in Sydney, various councils were also concerned about garbage, and they'd got the engineers had got their education in Britain, and so they said, okay, we should install incinerators here. And at Sydney City Council, their city engineer was actually sent on a study tour into the UK and the continent, and he came back with a very thorough and convincing report recommending that this type of incinerator be installed for Sydney. However, some ignorant alderman said, no, we can do better, that's too expensive, we should go for El Cheapo type of incinerator system. So there were a number of arguments, and of course nothing was done for several years. However, something happened to change all that attitude, and that was bubonic plague in the Rocks area spreading through the rest of Sydney. So all of a sudden the councillors realised that something had to be done about it, And then after rejecting the city engineer's report, eventually they were convinced that this was the right thing to do. So the system works where men shovel the garbage into this feeding hole here, and then it comes down the slope and then dries out to a large degree because of the heat coming from the exhaust gases from the burning. And then it goes on to a burning grate. You can see here, hot air is blown up through underneath it, sets it on fire. The fine material falls down through the grates into an ash pit, and then the big material, such as glass bottles and bits of steel, go shoveled out through these clinkering doors. Very effective, and it worked well. So, the first installations for incinerators were installed at Moore Park. So you can see Mr. Richards' report. He recommends Perfectus, which is the one that I showed you earlier. And eventually, even though it was ignored at first, there was a drive to do something about it after the death of a child, even in Moore Park. Eventually, a plant was installed, and then it had to be upgraded, because what happened was, it's the usual story. When you have a facility and people see that it works, they fill it. Is that a Peter principle? No, it's a different Parkinson's law. That's all it is. Yeah, there's effectively, once people realise that it worked effectively, then you'd have, say, Paddy's Market vegetable beef sellers would get all their rubbish and offcuts and material like that. Chinatown, all other people would send the material to the garbage incinerator, and in no time flat it was overloaded and it had to be doubled in capacity. So, 1933, the Perfectus unit was falling apart and inefficient, as you'd expect. You've got high temperature processes, steel work, eventually it corrodes, wears away, and its efficiency drops off, and you need to do something to replace it with more modern technology. So the council did the right thing, called for tenders, assessed the tenders, and the city engineer and health inspector decided that the best option was a company called RICO, Reverberatory Incinerator and Engineering Company. The architects for that company were the Burley Griffin Studio, and they already started work on clearing and foundations at Moore Park. However, work was stopped because the local citizens decided that they didn't want an incinerator in Moore Park. Obviously, the more wealthy people living around the edges of Moore Park. Not only that, they took it to court and won the case. So the Metropolitan Land Board ruled in favour of the protesters, and the council was not allowed to put in the new incinerator in Moore Park. So at Piermont, the council decided then if they can't put it at Moore Park, they'll install it at Piermont. There was already one here, which is of a similar design to the one I showed you previously. It used a boiler system based on a British design. So the RICO unit was put up and built, which is the one I showed before, the picture. And it operated, you can see there, for over 30 years, except the Clean Air Act came in 1961, and the emission standards that were required could not be met by the RICO unit, and therefore the Department of Health insisted that the incinerator be shut down. And then it was demolished, and housing was put in its place. Here's an example of what it was like to be one of the furnacemen on a typical unit at the time. So the garbage was put into bins and then dropped out of the bins onto a floor, and then these guys had to wade through it knee deep and shovel the material into what was called cells. These things here with the doors on them. Not a very appealing job. Whereas the Ryco system was much cleaner. The workers themselves had much better conditions. So now I'll describe the Ryco unit that you had here at Pyrmont. It was developed by two sanitation engineers from Melbourne who were already working in a big unit just like the ones you saw before, and recognised that as the suburbs expanded away from the city centre and grew because of the tramways, railways pushing people out into the suburbs, the catch was that these suburban areas also needed incinerators, but the catch was that the boiler system that I described beforehand was very expensive, complicated, and needed highly qualified people to run it, as you'd expect with high pressure steam going around the system. So these guys decided that something better was needed for outer suburbs and rural towns. And instead of having to pay over £20,000 for the boiler type system, they actually dropped the cost to around £2,000 for their system. So it was very attractive to councils. So they built 4 incinerators to that design. Sandringham, Box Hill, Geelong, and Bexley in Sydney. Okay, it was made as an attractive proposition because the 2 developers said to the council, we'll pay for the construction of the incinerator. Not bad, eh? And the council said, beauty, we'll get it for free. And they said, we'll only charge you for the capital cost of the incinerator if it works to the specifications that you set forward and also operates at a cost which already we've specified in the guarantees. And it did, so eventually the council paid them back. So this system worked very effectively. They also offered free training for 3 months for the furnace operators and a fixed price maintenance contract. So the whole gear was very appealing to councils that were short on cash, as you'd expect in the 1920s and the 30s. You could argue that what companies nowadays offer such a high quality of after-sales service? None. The catch was that the word got around that this was a successful and clean operation, and so other council engineers decided they'll go and have a look at it. So they did. There was a procession of people to each of these early incinerators, having a look, seeing how it works, asking the city engineer for data on their cost and operating maintenance performance of it, and came away very impressed and asked for a proposal or a submission from these 2 guys who were working full-time already in the Melbourne incinerator, and it was just overwhelming. They couldn't cope with all the inquiries. So they went for help. You can see here, one of the developers was from Ukraine, and he knew a friend in the migrant community called Nissan Leonard Kanevsky, who had extensive business interests in the clothing trade. So they asked for his help. Now this guy, Nissan, had already had a skyscraper built, which was designed by one Walter Burley Griffin. And that Walter and his team of architects had the studio within Nissan's building. So Here they have a great synergy of people that could actually set up a new company bigger than the previous one and really push through sales and marketing of their incinerator system. You had very good management from Nissan Leonard Kanevsky. You had the engineers themselves, Bodel and Trunoff. You had architects that could make an attractive building, the Griffins, and you had other engineering support as well. So away they went and were very successful in installing incinerators. That company dominated the market in the 1930s for incinerators. So, and they built them in Ipswich, in a number in Sydney, such as Randwick, Willoughby, here, Marrickville as well, and other places, and in Victoria and in South Australia. Essendon was very popular, and there were lots of people coming to have a look at that and see how it worked. So there are a number of factors which made it an attractive proposition for an incinerator. You can see here the health inspectors condemned the tips, which were quite common in that time, the smells, flies and rats. Glebe Council, for example, would put all the garbage onto barges and then put it out to sea and then dump it at sea. And you can imagine having dead dogs and other unmentionables floating up on the eastern suburbs beaches. The locals there were very hostile to that idea, and eventually they persuaded the Commonwealth to put in legislation to ban that practice. I mentioned beforehand the assistance with financing that the company developed, the training and guarantees that they put out. So it was a very attractive proposal. 3 months training, and it was actually cheaper than open dumping or putting it out to sea. So the sweetener in the deal was often because some councils were rather nervous about the idea of building an incinerator, and they would say to the various older men, no women of course in those days, why don't we build an incinerator in your word, Mr. Jones? No way, Mr. Jones would say, they'll cut my throat. Oh, no chance. How about you, Mr. Jones? Why don't we build in your word? Well, everybody freaked out and said no way. So eventually the councils had to put them usually out where there were quarries or their previous dumps, effectively on council land. So the councils also said, why don't we put into the specifications of the building that it looks attractive, that it doesn't look like an industrial building, that it almost would fool people into thinking this is a house or some other establishment, and therefore the resistance and opposition that they had to putting an incinerator anywhere within the council precinct would be overcome. These are the three guys that were critical in the whole system. Where are we? Here we are. Walter Burley Griffin, the main architect. His studio did the design work. This one here is John Bodel. He's the engineer that came up with the design of the furnace system. And Nissan Leonard Kanevsky. He's the managing director and the great marketing specialist. Here's an example of one of the early incinerators at Essendon in Melbourne. Yes, a very attractive design. It's still there and probably the best example of their Griffin incinerators in Australia. You can see the building looks nothing at all like an incinerator, does it? It's not a tin shed or a brick shed. with a square section. It's got an unusual roof system, and also even the stack has got patterns and appealing features on it, and it's not very tall, so people were quite astonished that an incinerator could work so well. Not only that, but the emissions from the stack were not black and smelly and smoky. It was just a light whitish colour without the smell. So here we are at the Piedmont incinerator. Here's a drawing of the layout of the system. You can see the effort that was put into the design of it. Even the stack itself has got all sorts of patterning on the brickwork. And then the building itself has got some marvellous features in that as well. So here we can have a section of one of the walls, incredibly detailed. There's some people that claim that this was being influenced by Aztec or Inca type architecture or Maya. That's great uncertainty, but effectively the key person that did a lot of the design work on the exterior of the building was Marion Mahoney Griffin. And she incorporated into that her philosophical ideas called anthroposophy. People there had a very close connection with nature and spiritual aspects of themselves, and they thought there were four fundamental ethers that they called them, not quite like fire, water, as in the old Greek system, earth, air, fire, water. These were a balancing of various ethers within the body system and also in the physical environment. So you can see here vitality, emotion, soul, Tao, spirit. From the garbage was actually returning to these four ethers that she mentioned: light, warmth, sound, noise, and energy that was being produced. So each of these forces were represented by different shapes. You can see rectangles, crescent, circles, and they're shown in the design of Piedmont. So some claim that it's not really Maya or Aztec or any other design like that. It was actually expressions of Marion's philosophy. So you can see here nested triangle arrangements, and that was one of her ethers. There are also rectangles and square systems as well. Now, here's how it worked. The trucks would back up, and I think there are about 10 different bays, so they could handle quite a few trucks at first. They would reverse in and tip the garbage from the trucks into this pit here. Now, this whole building was actually under negative pressure. In other words, the air was being sucked in through the doors so that the smell wasn't going out. And that was a key feature of their incinerator designs. So a clamshell bucket arrangement would actually take a bucket full here from the storage bin, and there were two smaller storage bins for each of the four furnaces. So it's a big unit, as you'd expect, because they had a fairly large capacity that they needed to get through. And then this crane would go up and down to fill these 8 bins, 2 for each furnace. Here's a schematic of the layout of a typical furnace system based on what they've done in Ipswich. You can see the truck comes in, dumps its load into a bin. This whole building section here is under negative pressure to stop the smell from getting out. It feeds into a hopper arrangement, and there's control fed down onto a drying grate. This is the drying grate here. So they recognised that the first thing you needed to do to have an efficient incinerator system was to dry the garbage first, because the garbage could contain up to 70% moisture, and therefore it wouldn't burn with that moisture content. So if you removed all that moisture, then the garbage would burn, because you've got paper, food, a whole range of different things that are combustible. After the drying, you go onto a furnace grate, and then any material falling through the grates would be collected in hoppers and then put into a little trolley, like a mine cart here. And then an important feature of them was this section here, which I call an afterburner, because when you burn garbage or coal or wood, you always get some sort of soot, organic material, tars coming off from the combustion process. So it's very important to burn them completely, because those things cause the black smoke, which was very common in the older style incinerators because of incomplete combustion. So the afterburner section here did the job of retaining the gases, mixing them up and then burning them effectively with extra air. After that, the material was collected and then could be cooled. This is a quenching area where water was sprayed on the hot ash, cool it down, then it could be dumped out. Now, the stack here provided the draft for the furnace system, so there was no fans, in the main furnace setup, but they had what's called a heat exchanger in this area here at the base of the stack, and what that did was pass the hot gases from the furnace through one side of the heat exchanger, and then the cold air, which they'd suck out of this section here to contain the smells, would be passed through the underside of the heat exchanger and then be heated up to around 250 to 300 degrees C, whereas the furnace gases were usually 850 to 1000 degrees C. So that was a very effective system, and no steam, no boiler system. You didn't need to employ a furnace engineer with a boiler ticket, so your cost could be quite low, because all you needed to run it was a relatively unskilled man and a boy. Therefore your labour costs were quite low. There's an oil burner, which was used to preheat the furnace, because almost all of the units operated only on 5 days a week, day shift only. That was the common way of operating. Piedmont was unusual in it was operating for 2 shifts a day, 5 days a week. And when there was a big demand, they could extend it over the weekend as well. So initially you had to use the oil burners to get the furnace up to temperature, and then once you start feeding the garbage into the system, you can shut the oil burners off. So the fuel consumption was quite low. You were using the garbage itself as the fuel. The other thing that was important up here, there were very simple control systems within the furnace. You had draft gauges up here, so you could control the amount of draft from the stack, so that you didn't have a system where you were blowing hot gases out of the furnace if anybody opened a porthole. And you didn't want too much suction within the furnace, because then you were sucking cold air. So here's an example of a battery of furnaces, which is in Brunswick. So you can see here all the controls that were needed to operate the furnace, such as opening up the ash bins underneath. This here is control the amount of air going to the furnace grates, oil burners. This is a mechanical system up here for putting in, operating what's called a rocking grate. they found that an important feature of working very well was that you had to break up any wet clumps of the garbage and spread it out effectively on the drying grate. And so they put in a system where effectively you had fingers which came up and flicked the material and broke it up and moved it down the grate. So these things here are what's called the rocking grate. So the Sydney City Council insisted that all systems should be mechanised and that the workers themselves should not have to touch any of the garbage. Very good. Up the top here you can see chains that operated a rack and pinion system to feed the material into the furnace as needed. So all the controls were on hand on one level. The furnaceman didn't have to go up and down to various levels of the system. Here's a picture of the rocking grate system as at Willoughby. You can see here, these things here were this mechanism for actually operating those fingers that broke up the wet garbage. There were the ports where the furnaceman could rake the material along. These are the controls for the airflow in the system, and then it's not showing the one where they can open up the ash bins. So here's a picture of the rock and grate system. It's a bit hard to figure out how it works, but it's very much like fingers coming up and down and moving the material along. Here's a layout of the system within the furnace. You can see here. So the feed material was in the bin up above. It was dropped down through a slide gate onto the drying grate. Hot air from the preheater was pushed in here through the bottom to dry the material. Then it was raked down onto a furnace grate system here. And then the operator would actually rake the burnt material off from the end. So in the combustion space above, you would burn effectively any gases that came off, any soot, char or any material like that, smells. This is the afterburner section, so this is the tail end of the whole furnace. So in here you can make sure that you finish the completion of the burning of the soot and any tars and volatile materials so that you had a fairly clean stack. Here's the heat exchanger system that I mentioned. This is from Piedmont. You can see the hot furnace gases went through these small holes here at high temperature of about 850 to 1,000 degrees C. And then the cold air, which had been sucked from the feed bin area, was around the outside of these pipes and transferred the heat. Here's a schematic of the furnaces at Piedmont in operation. You can see all the features that I mentioned, the twin rocking grates here, the oil burners, the various control systems for the bins, as well as the airflow. Up above here, the control system to open and shut the feed gate coming in. And you can see the men here raking the material out into the ash bins underneath. Piedmont had a very unusual ash transfer system compared with the other incinerators, and it was the only one to install what's called drag scraper conveyor. So the furnaces would be lined up along and discharging into this long conveyor system, and then it would be taken into a quenching pit and then from there pulled out with a clamshell bucket into a bin and then into a truck to be taken away to be dumped. The catch is that they're quite fragile. And if you have bottles, bits of steel, tins, things like that, they can easily get jammed in these chains that drove the system, or under these push blades a little along there, and they frequently have to actually put somebody in there and clean the whole system out, which was quite dangerous. Productivity and costs. The first ones that were built in 1930 could only cope with about 30 cubic yards per shift, a man and a boy. Operating costs are around $1 per cubic yard, which is quite not bad. Well, so as the partners in the business gained more experience, they started building bigger and bigger furnaces to carry more load, because if they wanted to get contracts from big cities, they needed bigger furnaces and more, and so instead of just one, you needed 4 for places such as Hammond, because of the amount of material being treated. So they put in extra systems such as these shaker grates, bigger furnaces, higher temperatures, trucking costs were cut down. Sometimes several councils would share the cost of one incinerator. There were problems. The fact that I mentioned beforehand it might only operate for 1 or 2 shifts per day meant that overnight the furnace system would cool down. And if you've got refractory bricks within a furnace system, which is the way they were designed, they don't like temperature cycling like this, because the bricks themselves expand and contract, and they can actually get cracks in them and bits and fall. The best way to operate a high temperature furnace is to get it up to temperature, hold it at that temperature forever. However, this system here, they were focused too much on reducing the operating cost by having a system where they're only working it for 1 or 2 shifts a day. And that was the penalty they paid in having the brickwork fall out. And that happened here at Pemont a number of times. I mentioned the mechanical systems were playing up. Concrete cancer, they weren't aware at that time of how concrete cancer formed and what to do about it. And I mentioned beforehand that drag scraper conveyor was getting jammed regularly and holding up a system. And also with the advent of plastics, which gradually came into effect, they started to melt and actually clog up the gaps between the grade systems. In the early days of the 30s, the only plastic around was Bakelite, whereas as you went on into the 50s and the 60s, there were a whole range of different plastics, some of which were not only melted and got stuck in between the grades and clogged them, but also emitted all sorts of nasty toxic materials from combustion of plastics. So, I mentioned beforehand that Sydney's in trouble because your dumping system will be running out of room within 4 years, and you'll have to do something about disposing of the garbage. This is a modern incinerator system in China. In China, they have more than 1,100 of these units. In Japan, nearly 100. In Europe, there are over 550. So it's not as though it's new technology, it's well established and meets the very tough emission standards of the European. How does it work? If the flow sheet looks complicated, that's because it is, because of all the various components that need to be cleaned out of the gas system before it would meet the emission standards by the various environmental protection authorities. So first you put the garbage in to a bin. There's a travelling grate system here where it's burned. The ashes come out of the top, the big stuff, and then the flue gases come up through this system here, and there's boiler tubes inserted into that, and then they add ammonia or urea. And what that does is convert the nitrous oxides, which are nasty pollutants, into nitrogen, which is fairly harmless. The next stage is a boiler, and they raise steam, and that steam is used to drive a turbine and generator system to make power for the grid. So they can make often several hundred megawatts of power. After it's been through the boiler system, they inject lime, an active carbon, that converts the sulfur dioxides into gypsum and mops up any residual nasty things such as dioxins and furans which come from burning of plastics. Then it goes into a baghouse to remove the particulates, and then finally into a stack. So you can see why the flow sheet is so complicated, because there are so many nasty compounds in the flue gases that need to be cleaned out before you can put the flue gas up the stack and recover the energy from the hot gases through a turbine and generate power from it. So that's how a modern incinerator system works. Now, Walter had this vision from his experience with building incinerators that were just very impressive designs, and some of them even look beautiful. He had this vision where if you built an industrial building, it wasn't necessary to have it looking strictly functional and therefore fairly ugly. And did he succeed in that mission? Well, here's an example of a steelworks, the blast furnace system used for making the pig iron. The focus is entirely on making access available easily so cranes can come in and do maintenance work on the various units in the whole blast furnace system. Here is what's called TSL, or top submerged lancing furnace. This is state of the art for smelting nickel, copper, lead. And there are a number of installations. This one's from Port Pirie. There's also another one at Mount Isa, and many overseas. You can see here again, function as the driver, where these panels on the side can be easily removed so they can get cranes in to do maintenance work on the building. So I could say that Walter's vision has certainly not taken root, and I haven't seen any industrial buildings that would be appealing in the same way that the Piedmont and the other incinerators were. I'll finish up with just to show you what it was like. Now this is the tail end of the Piedmont incinerator. The truck that you see in there is the one that takes the ash from a bin and puts it out for as clean fill. So the work that was put into the design of the walls and the building systems around that, you can see there the sandstone walls on the edges. So for something that was, you could say, was the arse end of the plant, was still very impressive and beautiful. And that's what the Burley Griffins achieved. That's it. That's it.
Thank you.
Thank you, Jim. And we're open for some questions. Can I sort of have the first one? What about? Tell us a bit more about Marion and her role in all of this. She described this as her best work.
So in the book that she wrote eventually, Marion said that she was the most proud of the Piedmont smelter, as she thought it was her best design of an industrial type building. But of course she was involved in numerous other buildings as well, together with Walter, such as houses, Newman College, and I think her specialty was probably the interiors, and the best example that I've seen is the Australia Cafe at the Australia Hotel. If you've seen any photographs of that, it's just magnificent. So yes, although it was normal in those days for the woman to have a low profile, and the husband did all the discussions, negotiations, and was the front person effectively of the studio. But she had, you could argue, she had more architectural experience than Walter did with Frank Lloyd Wright Studio, and was involved in a lot of activity when she was in America and building some marvellous houses. So yes, her contribution is certainly not very acknowledged.
No, with the facade,
when they pulled it down in the 70s, did they try to keep any of the facade to, like, did her designs to put anywhere else to display, or it's just rubble? Like the walls.
Michael, do you know anything about that?
Quite a lot of tiles, the decorative tiles were sort of applied on, and while it was being demolished, members of the Walter Burley Griffin Society were carefully recovering them, and quite a few of them are in the Powerhouse Museum collection. They're not normally on show, but we're hoping that we might organise in the next 12 months a visit to the Castle Hill Discovery Centre and ask them to put out some of the tiles. There's also some of the machinery brass plaques, some of the steel fabricated gates and doors. So there is quite a lot of smaller things, and a couple of artists have interpreted the Piedmont incinerators. Some actually some white jewellery inspired by the Piedmont incinerator, created by the designer who I've forgotten. I'm not quite sure if they're white plastic or even ivory or something like that, so they could be part of a collection. They also have some remarkable lead light windows from the Capitol Theatre in Melbourne. So if we can organise that, we'll certainly let you guys know, and if you want to come along on whenever we can organise it. It won't necessarily be this year.
Well, it seems like incinerators are pretty dangerous places to work in. Were there ever any accidents in Australia?
Yes, there were, at Piedmont as well. And what happened was that they suspect that some people put in souvenir bullets and shells that they brought back from the war into the garbage, and they naturally exploded once they're in the furnace. And John Bodle at one time was injured when the doors blew off and some material rained out on him. So that's the sort of accidents that can happen, and that's happened in some other incinerators as well. Apart from that, in terms of people being caught in machinery or burned, I don't know of any instances at all, because you can see that they deliberately aimed, and the Sydney Council insisted that the men would not handle the garbage directly.
Thanks, that's very interesting. I imagine too, if there was an accident, then that would stop production for a while as well, which would be quite inconvenient, I imagine.
Yeah, yes, it would, and then they'd have to resort to open dumping somewhere else.
Thank you, that was very interesting. I never knew there was so much involved with incinerators.
I believe there is one in Willoughby, the same as the one in Piermont, that hasn't been destroyed. Is that correct? It used to be open as a cafe, and I haven't heard what happened to that one. Do you know anything about that one over in Willoughby?
I do. And you can go and visit it and have a look at it, because the exterior of the building is still there. The stack has been changed into something more modern and less attractive. The top floor is converted into a cafe, and the lower floors are now art space where various artists put on exhibitions. But fortunately, I showed you a picture there of one wall of the furnaces with some of the equipment already attached to it. So that was pretty well identical to the Piermont furnaces.
Aaron Bollett was Aaron Bollett was an integral part of the architect input for this cinema in Piermont, who was a designer of cinemas, notably the Randwick Ritz, and also a number of apartment buildings around Sydney. But his principal role was as a cinema designer, and I believe at that stage he worked for Burley Griffin. And design was, although he got a little recognition, I think he was responsible for a lot of the design in the Piermont incinerator.
What was the name again?
Aaron Bollett, B-O-L-O-T.
Don't know.
Yeah. Okay.
Where was the Piermont incinerator?
Just off Bank Street, on the curve there. My question is, I've heard controversial sort of comments about Eastern Creek, that incinerator that's been proposed, and you mentioned we're running out of landfill. What's the immediate future? What's Sydney County Council considering? What are the solutions looming?
Because of the resistance, the idea of putting in a modern incinerator at Eastern Creek, the council now, their favourite approach is to have a system where they take 6 train loads of garbage every day down to Parks and install one of these modern incinerator types as I showed. And naturally the people in Parks, well, some of them are not very impressed at all and don't want it.
But there's no construction underway.
No.
Isn't there an old mine south of Tawago with garbage going in there?
I don't know.
Yes, that's right. That's where Sydney garbage goes.
That goes by train.
And I worked at that mine, and they're making more money filling the hole up than what we've made digging the hole. One last question. Thank you.
Just curious, where was the Moore Park operation? Whereabouts in Moore Park was the first one?
I believe it's on the western edge of Moore Park.
Any evidence of it now?
It's down hole number 9.